Hello, good morning, everyone. So yesterday we started with the lab of Dmvpn Phase 3. So if you talk about Dmvpn Phase 3, so you will be configuring MGRE on the hub, MGRE on this port, and on another spoke also will be configuring MGRE. So the only difference is you will be enabling IP NHRP redirect on the hub and IP NHRP shortcut on the spokes. Can you tell me what this redirect and shortcut command will do? Why we enable this?
Rewrite the short path.
Very good. So that your R2 and R3 will have specific entries in their routing table. That route we call it as H route, that is NHRP. Okay. So let's quickly do this. So we'll be enabling today. So I've shown with EIGRP and BGP, right? So we'll be again doing EIGRP, OSPF, and BGP. So we'll quickly finish this, then we'll move on to IPsec. Let us say by default all in downstream the interface. This range. So go to R2. Interface. So we are not enabled redirect and shortcut command. Right? So just go to IP NHRP shortcut on the spokes. On the hub is IP NHRP. So I have a summary here. So that's why we don't require split horizon and next one disable this. So IP split horizon. Next option. So my configuration is show run interface. So I have only the summary. Okay. Let's move on to R2. So R2 will have IP route. Yes. Default route. And R3 also will get a default. IP route. Yes. No, ping. 2.2.2.2. We will do trace. Able to reach in one. Check the routing table. We'll create a H route. Can you see here? H route. Specific. So we don't require to disable split horizon and next stop self on the hub in Dmvpn Phase 3. If we can send a, we can do summarization in Dmvpn Phase 3. Clear? This is about EIGRP. So now we'll remove EIGRP. and we'll enable OSPF. Use a different process ID because one process is already running in your underlying network. So no router, 123. So I'm removing EIGRP and enabling OSPF. Done. So go to R1 and use different process. Let me use router 123. Network. I need to enable the tunnel network 172.16.123.0 wildcard mask and area 0. Enter and the loop package. Enter. So go to R2 and enable. So router 123 network 116.123.0 wildcard mask and area 0. Need to enable on loop package. Then so enable OSPF on R3 as well. Network 16.123.0 wildcard mask and area 0. Network 3.3.3.3. Yeah. They'll form the adjacency. So why it is flapping? 1 minute. Yes. Why this is flapping? No. Split horizon. Why it is flapping?
Network type.
Network type is what? Point to point. By default, OSPF treats the network type as point to point, first class. So if you check, no logic console. Show IP OSPF. Do show IP OSPF interface tunnel. Can you see what it is treating as? Point to point. What do you mean by point to point? It can either establish with spoke 1 or with spoke 2. So on a single interface, it can't form adjacency with both R2 and
Multiple sports.
that's why it is flapping. So one important thing to remember, in DMVPN, you can't use OSPF network type as point to point. Please make a note. So you can't use OSPF network type as point to point. In DMVPN. Please note on the timers as well. It uses hello as 10, dead as 40. And neighborship is dynamic. Note on 3 points. So second point is, if we talk about hello and hold, it is 10 and it is 40. What is the third time? What to say? Third type, it will be dynamic neighborship. And in point to point also, there is no DRB election. Check. Is an exchange state. Can you see here dash? Means there is no DRB election. Please make a note of that as well. So no DRB election in point to point network. Three very important points to remember in the interviews. No DR, BDR election.
Chetan, why it is showing full DR to R4?
That is your underlay. This is your underlay network.
Okay.
This is flapping. It is not showing, but it is what to say. There is no DR-BDR election. It's not showing because it is flapping. Can you see? It goes up, comes down, goes up, comes down. So that's why we don't have a DR-BDR election. Clear? Now we'll change the network type to broadcast. How to change that?
Interface level.
Interface level. So interface tunnel 0, IP, OSPF, network. Question mark? It supports broadcast, non-broadcast, point-to-point, point-to-multipoint broadcast, and we have point-to-multipoint non-broadcast as well. So now go to R1 and enable broadcast. Enter. So go to R2. Interface tunnel 0, IP, OSPF, network, broadcast. Control one more key point to remember. What was that? When we do it as broadcast or non-broadcast. Annual labor good. One. Another point. Hello and hold is 30 and 120. That I will show you. Other than that, your spokes should never participate in the DR-BDR election. So you should disable the capability of the spokes so that they will not participate in the DR-BDR election. How to do that? Happy OSPF, priority.
Priority 0.
Go to R2 and set the priority as 0. Now. So now if you check, show IP OSPF interface tunnel 0. So what is the network type here? Broadcast. Can you see the timers? It's 10 and 40. Please make a note. Any doubts? So if you check the neighborship, here, can you see? This is not over the tunnel. So it is confusing. See, over the tunnel it has not found membership because you need to type section. So I need to enable the neighbor. It is confusing. Don't confuse. Router OSPF 123. So neighbor. For R1, we have neighbor 172.16.123. So otherwise, let me remove and put default route. Shall I do that? Is it confusing? Confusing? Clear? What is clear? Tell me. What I told just now. Okay, so we don't have any adjacency over the tunnel. Why? Neighborship. Let me reverse no router. I create a default route. So IP route. What is the next route? 192.168.14.4. So it will not be confusing because it is forming three adjacency with in the underlay. This is underlay neighborship, not overlay. Confusing. So let's go to R2 and remove one. So no. Create a default route. .192.168.24.4 and on the R3 as well. No router. One. So IP route. 192.168.34. Second ping 192.168.24. Good reach. Now if you check show IP OSPF neighbor, I don't have any neighborship. Wow. Wait for that timer to expire. Just wait. That enter will go. It is getting a yellow packet. Run pipe section. Okay, didn't remove on R4, right? So go to R4 and remove. It should not show the neighborship. The center will go. So hold on tight. Again, it is getting hello packet. It's 10, right? By default, can you see? It is again refreshing to 39. Means it's getting a hello packet. So go and check on R1. OSPF here. Enable OSPF here. How it is forming neighborship at 14.1. So did I enable show IP OSPF interface brief? I don't know where all OSPF is enabled. We enabled on the tunnel and the looper. That is fine. So go to R2, check show IP OSPF interface brief. Want to know where all you have enabled OSPF. Tunnel and loopback. This is fine. Go to R1. How you trouble interface. Tunnel and loopback. 100% bug. I'm not enabled OSPF. So it is forming the adjacency. Interface. You see, I'm not enabled OSPF anyway. Enabled for ProSID 123. But if you check the adjacency here, no. So on R1, show IP OSPF neighbor. It's a pure bug. 1 minute, I'll just shut down. Save the routers, shut down and bring them up. Reload. Just wait. Interface is 0.0. R3. Back to R1. Using the broadcast network type, so they will automatically form the neighborship. So I think OSPF. Now it is fine. It was a pure bug. Can you see? It was showing the NVMe IP. Where is the NVMe IP? Sometimes even EVNG has bug. Can you see now? Now it is clear. And can you see who are DR others? These both spokes are DR others. So they are not participating in the DRBD election. Why? Why do not participate in the DRBD election? Yes. Very good. What is the by default priority of OSPF? 1. So okay, now. So what are the points? We have noted down. Show IP OSPF. The type is broadcast. Hello and dead timer is 10 and 40. So we have dynamic neighborship here, and we have DRBD election. Show IP OSPF neighbor. We have DRBD. If you go and check on R2, so R2 will show 1.1.1.1 as the DR. Show IP OSPF neighbor. Can you see? This is the DR. And this will be always DR other. Why? Because we have set the priority to 0. Clear? Please mention. We have DRBD election in broadcast network type. And the timers are 10 and 40. And we have dynamic neighborship. So in broadcast, we have DRBD election. So hello is 10 and hold is 40, 40, and we have dynamic neighborship. Three points. The okay. So now we'll change the network type to non-broadcast. Sure. This. So IP OSPF network non-broadcast. Enter. So go to R2. Sure. Go. Remove this network type and configure IP OSPF. OSPF network non-broadcast. Why neighbor is down? Why my neighbor is down? My neighbor has went down, right? Why? Yes, online guys. Yes,
Network
1 minute.
type
Mohammed
was
Ashik, 1 minute,
same.
1 minute, 1 minute, 1 minute. Mohammed, are you there?
Sir,
Why it went down? Why my neighborship is down?
so it might be because it turned on to point to point.
No, my neighborship is not flapping.
So network type need to
Yes,
same.
network type mismatch because on R1, no, it was what is the network type? We have made it as non-broadcast, whereas on R2 and R3 we have broadcast network type. So for OSPF neighbor adjacency, your network type must match. Make a note. Network type. So no neighborship criteria. Wow. What are the neighborship criteria for OSPF? Yes. It's one by one. Yes, who will start? Same area ID. Good.
Area type should match.
1 minute. Yes. Area type must match.
Network type should match.
Very good. Network type must match.
Authentication.
Very good. Authentication must match if enabled.
Hello, the timer.
1 minute. If enabled. So timers must match.
Subnet should match.
Which one? Which one? Common
Subnet.
subnet. Good. Common
Yeah,
subnet.
subnet.
Yes. 1 minute. 1 minute. So if we don't know, please make a note. Timers must match. So then common subnet. Then
MTU must match.
unique router ID. Good.
Yeah, unique router ID, MTU.
MTU must match.
Passive interface shouldn't be
Very
enabled.
good. Super. Who answered this? Who answered this? Passive interface.
Me, Ashik.
Did with CCI
Sir?
coaching? Did with CCI coaching?
No.
Okay. So passive interface should not be enabled. What do you mean by passive interface? Yes. What
They
passive
don't,
interface will do?
It won't share
Yeah.
hello.
Yes.
Don't send hello.
It will not send hello packet. Passive interface should not be enabled. So these are the points you need to remember when your OSPF adjacency is not forming. It may be one of these reasons. This should be in the head, not in the notebook. Timers, common, unique, MTU, passive. Any other point?
Chetan, just a doubt.
Yes, tell me.
When we configure this passive interface, right?
Mm-hmm.
We usually configure the LAN interfaces, right?
Tell me.
We usually configure passive interfaces to the LAN interface, right?
No, you need to go to router OSPF. Yes. Correct. Yes.
Yeah, usually into LAN interface.
Yes.
Okay. When we enable, I mean, let's say we have R1 router and our LAN is 192.168.10.0 and our WAN is 200.20.20.20. When we create an OSPF, a router OSPF 100, network 200.20.20.20.0. In that case, we are not adding LAN.
Yes. So why we enable passive interface?
Yeah.
Just to stop sending hellos, right? Where you enable? Connected to PCs.
Got
Because
it.
PC, you are not forming any neighborship with the PC, right? So I don't want to send a hello packet here. Even if I have a loopback 0 here, even I don't want to send your hello packet to loopback 0. Why? Because every 10 seconds, your hello packet will be sent. You are wasting your bandwidth and memory, right? So that's why
got it.
Yes, okay. Passive interface on the loopback or on the host connected interfaces, just to disable sending your hello packets. Okay.
Yeah, thanks, Chetan.
Okay, no problem. What happened to AC? Okay. So now, you need to go to R2 and R3 and change the network type. IPOSPF network, non-broadcast. Go to R3 and change the network interface. Not 0. So IP OSPF network, non-broadcast. Now go to R1. Show IP OSPF interface, turn on 0. So network type, not broadcast. Can you see here? Timers are changing. So whenever somebody asks you what are the timers of OSPF, it depends on the network type. Don't tell 1040 or either 30 or 120. It depends on the network type. Please mention this. Hello is 30 and dead is 120. And we have DR/BDR election, but we don't have dynamic neighborship. Can you see? I don't have any neighborship. You need to go and enable neighbor. And so go to under router OSPF1, use neighbor command 172 16.123.2 and neighbor 123.3. So go to R2. Go to hotel. OSPF 123, right? 123. Sorry, maybe I'll check. 172.16.123.1. Here and so router OSPF 123. Sorry. Router here 23. So what I need to enable? I only forgot. Why I came here? Router OSPF 123. Neighbor. 172.16.123.1. So go to R2. So we remove no router. Here, one. So router here 123. So neighbor 172. Yes. Tell me. Is done? Okay. What about R3? This is also up. I have not mentioned. So it is not mandatory. You can go and enable only on the hub. That is more than enough. Can you see it has formed? I am not enabled. Check do show run pipe section OSP. I am not enabled any neighbor command here. So if you enable neighbor command on the hub, that is more than enough. But for practice, go and enable. That is neighbor command here also. Neighbor, it's not. This is not there. That's very irritating. So OSPF 123. So neighbor 172.16.123.1. Now if you check show IP OSPF neighbor. Can you see we have DRB direction here? Who is the DR? 1.1.1.1 is the DR. If you go and check on R1, we will show you DR other. Why? Why DR other? Because we have set the priority to 0. Done. So noted down neighbor command you need to use. Okay. So now we'll change the network type to point to multi-point broadcast. So go to interface tunnel 0. So just remove no IP OSPF network to non-broadcast. That neighbor. And remove the network type. So no neighbor. So go to R2 and R3 and remove the network type. Yes. 0. Router OSPF 123. So no neighbor 172.16.123.1. Go to interface channel 0. No. No IP. Here. Network. Right on that this one fan or open this. Very irritating. Am I able to perform? That's why we're unable to tell the answer, right? AC is not good. Open the door as well. So go to R3. Do show run pipe section. So router OSPF 123, no neighbor. Interface, tunnel 0, no IP OSPF, network, non-broadcast. Okay, so now we'll go to R1 and enable the network type as point to multipoint broadcast. So IP OSPF, network, point to multipoint. Enter. Go to R3, interface, tunnel 0, IP OSPF, network, point to multipoint. So go to R2, enable the same. Tunnel 0, IP OSPF, network, point to multipoint. Now go to R1 and check show IP OSPF, interface, tunnel 0. So what is the network type? Point to multipoint. What is the hello and dead? 30 and 120. And we have dynamic neighborship and no DR BDR election. Show IP OSPF. Can you see? We don't have any DR BDR election. Please make a note. So no DR BDR election in point to multipoint broadcast. No DR BDR. So hello is 30 and hold is 120, and we have dynamic neighborship. Done. So now we'll change the network type to point to multipoint non-broadcast. Final network type. So do show run interface transfer. Now we will enable network type as point to multipoint non-broadcast. So IP OSPF network point to multipoint non-broadcast. Enter. So go to R3. So IP OSPF network point to multipoint non-broadcast. Go to R2 and enable the same. Channel 0 OSPF network point to multipoint non-broadcast. Enter. Show IP. Yes. OSPF interface. It will show it as point to multipoint, but we have enabled point to multipoint. This is a bug in event section OSPF. So we have enabled point to multipoint non-broadcast. This is a bug in event. It will show it as point to multipoint. Okay. So show IP OSPF. Why? Why no neighborship? Because you need to use a neighbor command. Because you need to statically configure your neighbors. Go to router OSPF 1. So neighbor 172.16.123.2 and 123.3. So router OSPF 1 neighbor 172.16.123.1. Go to R3. So interface. So router of 1 neighbor 172.16.123. Show IP OSP neighbor. Show run section. So now just copy paste this. Here also did the same. There for me. Show IP. OSP. So no DRB direction again. Non-broadcast. What is the timers? 30 and 120. Show IP OSP interface. And static neighbor format. Points to note, no DRB election. So hello is 30 and hold is 120. And you need a static neighbor command.
So whenever you need the network type, then how which is pointing point or you need the network?
Means I didn't get it.
So you don't point to the fully network down IPS network type. There's a point.
You are asking which is the best.
No, the best. Point to multi-point domain किया है.
हाँ.
तो अब उसको remove कर दिया. तो वो किसके switch होगा?
Broadcast BMA. Broadcast. Yeah. So now final thing. Let's quickly enable BGP to finish it. Comfortable with BGP? Should I enable and show once again? BGP? Should I enable and show? Or is it comfortable? Should I enable? Okay. So this is in ASN 123. So we'll first enable IBGP. So go to R1 and remove the, so no router, SPO 123. Okay, let's quickly enable BGP. So router BGP 120. So neighbor 172.16.123.2. Remote AS will be 123 and 123.3. Remote AS will be again 120. And advertise the network 1.1.1.1 mask /30. Go to R2, go to BGP 123, neighbor 116.123.1. So remote AS will be 120. Address the network 2.2.2.2 mask /30. So R3 router BGP 120. Neighbor 172.16.123.1. Remote AS will be 123. Advertise the network. Mask /. Yeah. Now go to R1 and check BGP adjacency. Show IP BGP summary. I have two adjacencies. Show IP BGP. So I have 1 and 2. Wait for 3 because we didn't advertise on R3. Just let's see whether R3 has advertised. Next stop will be always 0.0.0.0. Why? Locally injected routes. So it has injected. Wait. This is valid path. So it has not selected at the best. Just wait. The adjacency. No, adjacency is formed. Yes. We can clear. Clear IP BGP star soft, right? Can do that just to get the updates. So now it is fine. So go to R1. I have this. So now if you go and check on R2 and R3, I don't have any information about R2. 2.2.2. Why? Yes, online guys. Why I'm not getting the information of R2? That is 2.2.2.2. Yes, BB Mohammad Ashik, Salva Kumar, Tarun Patel. Yes, split horizon because of IBGP split horizon. So how to solve? Full mesh. Very good.
Full mesh or roof reflector.
Okay. So router. So BGP 123. Or we'll directly configure router reflector. So how to configure router reflector? So go to R1 and tell who are your clients. So do show run pipe section BGP. So router BGP 123. So just copy 123.2 and route reflector client. Enter. So another neighbor and route reflector client. Enter. So I have BGP. Go to R2. So I can you see I have the information of 3.0 using router reflector. First thing and trace. One how? Because Dmvpn Phase. Okay. This is about IPGP. So now EBGP. Change the ASN to 1. ASN to 2. And ASN to 3. So no router, BGP 123. So now we'll enable EBGP. So on R1, so router BGP 1. So neighbor 172.16.123.2 and remote SLP 123.3 and remote SLP. We advertise the network 1.1.1.1 mask /30. Then on R1, so go to R2 and R3 and enable BGP. Router BGP 3. Neighbor 172.16.123.1. Remote should be 1. Address the network 3.3.3.3 mask /30. So go to R2. So router BGP 2. Neighbor 172.16.123.1. So remote S will be 1. Address the network 2.2.2.2 mask /30. So now R1, show IP BGP summary. Consistency, show IP BGP. Just wait. Here, IP BGP star soft. Go to R1. Show IP BGP. Oh wow. What do you mean by SC? First time I'm seeing this man. Yeah, so delay. So BGP is slow. Show IP BGP. I have 3 loopbacks. So on the R3 also I have 3 loopbacks. And on the R2 I have 3 loopbacks. So ring and trace. Clear? So till here, anybody has any doubts? This is about EHRP, OSPF and BGP. Any doubts? Clear? So now we'll talk about IPsec. So IPsec stands for Internet Protocol Security. So now, what is the first question? Why IPsec? Good. So why we require IPsec? Nobody has any idea?
Authentication and
Very good. Encryption. So it is a suite of protocols. Suite, or we can call it as collection of protocols that is used to provide. Sorry. That is used provide encryption and authentication over an IP network. So why we use IPsec? Because your normal GRE will not provide you encryption and authentication. It will provide only encapsulation. So in order to provide security, we use the concept of IPsec. Clear? Now, so there are a few protocols you need to know about. Yes, confidentiality, integrity, and authentication. So protocols of IPsec. So we have AH, authentication header, and we have ESP, encapsulation security payload. Payload, so if we talk about AH protocol, So let us consider we use this protocol. So this protocol only provides us the authentication, but no encryption. Provides authentication. But not encryption. So whereas ESP, this protocol provides both encryption and authentication. So that's why most widely used is your encapsulation security payload. So if you want to learn deep about this AH and ESP, you need to go to security. So now, so in order to establish IPsec, we have two phases. We have phase 1 and we have phase 2. Not SCS. We have phase 1 and we have phase 2. So in phase 1, we create IPsec tunnel. Sorry, not IPsec, it is ISACMP. Very sorry. It is ISACMP tunnel. ISACMP. And in phase 2, we form IPsec tunnel. So if we talk about ISACMP, the full form is Internet Security Association Key Management Protocol. So it is Internet Security Association Key Management Protocol. So IPsec, Internet Protocol Security. Okay. So now, if we talk about phase 1. So in phase 1, again, we have two modes. So we have main mode and we have aggressive mode. And in phase 2, we have one mode, that is quick mode. So in phase 1, you can either use main mode or quick mode. Sorry, main mode or aggressive mode. In phase 2, we have only one mode, that is quick. So if we establish a tunnel with main mode, there is a 6 message exchange. In aggressive mode, we have 3 messages. So in quick mode, 3 messages. Six message, 3 message, and 3 message. So always preferred is main mode with quick mode. So means we have total 9 message exchange, 6 plus 3. So we don't prefer aggressive mode because there is no encryption and authentication in aggressive mode. because a hacker can easily hack this aggressively. So we don't use this mode. But in the interviews, we need to tell both the points, main mode and aggressive mode, and we have quit. So now we'll see the 9 message exchange with main mode and quit. So let us consider we have a client and we have a server. Not sorry, we have initiator and responder. It is for TCP, client and server. Make a chat. And very important for your interviews, this 9 message exchange. So main mode plus quick mode. 6 message plus we have 3 message, total 9 message exchange. So first message is from initiator to responder. We call this message as essay negotiation. I'll talk about this. What do you mean by essay negotiation? SA stands for Security Association. And one more key point I forgot to tell. So IPsec was found by IETF. Please make a note just for your extra knowledge. Nobody will ask what is IETF. So it is Internet Engineering Task Force. Please check the full form of this once. Go to Google. Just check, is it right or wrong? IETF. In mid 1990. This is the year. Internet Engineering Task Force. Okay. In mid 1990, it was.
14 Jan 1986.
Yeah, in mid 1990s. 86, sir. Wikipedia? Trust Wikipedia. That is. Okay, it was found in 1986. Right? January 14th. Just for your knowledge, nobody will ask. But OSI they will ask. OSI was found in which year? Which year? 19? Which year? OSI. Good. Last one. One is remaining. 1984. What about TCP/IP? 10 years before? 1970s. Who implemented TCP/IP first? ARPANET. 1983. Who found OSI?
DOD.
ISO. What is the full form of ISO? International Organization of. No, I'm not talking about ISO. International Organization of Standardization. It's the opposite. What about TCP/IP? Who found TCP/IP? No. Who found TCP/IP model? It is DOD, Department of Defense, US military. Fine, come back. So I say negotiation. So second message is from responder to the initiator. Again, he will negotiate his SS, his security association. SS stands for. So inside the essay will contain haggle information. HAGLE. Hashing, authentication, group stands for Diffie-Hellman group, lifetime, and encryption. This is what this essay contains. And both should negotiate with the same haggle information. Hashing must be same on both the initiator and the responder. Authentication must be same, group must be same, and encryption must be same. If lifetime mismatch is there, that is okay. So by default, it is 86,400 seconds, 1 day, 24 hours. Let us consider on the initiator, my lifetime is 3,600. And on the responder, it is 86,400. It will negotiate to the least value. Same like your EHRP. What is the EHRP hello and hold time? Very good. EHRP I'm asking. 5 and 50. It's 5 and 50. No problem. Just revise. So this is the first message, and both will negotiate the essays. So in the essay, it contains haggle information. Done. And these two messages, you need to configure it manually. Just let me. One and two are manually configured. Means we have a command for this. We see the command afterwards. Manually configured. Now, third and fourth message. So third and fourth. So here it will exchange the Diffie-Hellman key. And this is auto-generated. Diffie-Hellman key exchange. These two messages, third and fourth, are automatically generated. Means we don't have any command to generate this. Automatically generate. Diffie-Hellman key. Diffie-Hellman. So how the process works, you need to go to the internet. We'll see how they exchange the Diffie-Hellman. One Bob will be there, one Marley will be there. Somebody. They'll show you the exchange. I forgot, I think. Public is there, private is there. They will exchange the mixture. I think this is the thing. See in the internet. Better. Okay. Auto generate. Now, fifth and sixth message. So one more key point to remember, till fourth message, we don't have encryption and authentication. So in fifth and sixth message, we have authentication. This is about phase one. And these both you need to be manually configured. Means we have a command. This is phase 1. Now, 7th message.
Six messages, phase two.
This is 6 messages of phase 1. Phase 1 is done. Now, 7th message. Seventh and 8th. Seven and 8th. So here we'll use ESP or H. I talked about two protocols. So two protocols are used here. We call it as transform set. TRAN, yes, FORM, transform set. Here we have some algorithms. You need to select either AH or ESP, but the more secured one is ESP because it provides both authentication as well as your encryption. So if you use AH, then it only provides you authentication. Then 9th message will be from the initiator to the responder, that is acknowledgement. And these two messages are manually generated, manually configured. Sorry. And this acknowledgement automatic. So here you will specify your algorithms. Either you can use AH or ESP algorithms. So this is about 9 messages. So let's take a 10 minutes break. We'll come back and we'll go with the configurations. We'll see the configurations. So we'll come back by 12:32. So the protocol responsible in order to exchange these 9 messages is IKE, Internet Key Exchange. We have IKE version 1 and version 2. This is IKE version 1. Okay. Internet Key Exchange. So again in IKE, we have two versions, IKE version 1 and IKE version 2. So what we discuss now is IKE version 1. So version 2 will study in CCI Enterprise. Done. So let's proceed to lab. So now how to enable IPC? It must be same on R2 and R3 as well. First, crypto ISACAM. First, need to create a policy with the policy number. So I'll use 1. So now you need to provide the haggle information. First 2 messages we exchange SA negotiation. So you need to provide 5 information, that is haggle, hashing, authentication, group, lifetime, and encryption. So hash. So you can use any hashing method. Strongest is SHA 512. You know, SHA 512. Enter. Then authentication. So we'll use pre-share here. This is used by your remote VPN. So we have 2 types of VPN, site to site and remote VPN. So in our syllabus, we have only site to site. Remote VPN, you will study in CCI security. So we'll be using only pre-share. What do you mean by pre-share is, we'll be sharing the keys with the initiator and the responder through an email or via phone or any other. Enter. Next, group. This is your Diffie-Hellman group. So these are the Diffie-Hellman group you can use. So if you are going to write an exam, they will provide in the task what group you need to use. So for the lab, we'll use 5. Enter. And lifetime. So by default, lifetime is 86,400. That is 24 hours. So we'll configure 86,400. That is 24 hours, 1 day. Enter. And encryption method. Either you can use DES, 3 days, or AES. We have 3 types. Advanced encryption standard. We have DES, data encryption, and the most secured is 3 days. This is algorithms. So we'll use 3 days. Don't ask what is AES and DS security. So 3 days, enter. So this is the first 2 messages, and this must match on all the routers. Just copy paste, show run, pipe section, ISACAM. Just take this and copy paste on both the routers, that is R2 and R3. Go to R3 and copy paste. So 3rd, 4th message are automatically exchanged. Now 5th and 6th. So you need to create a key. The command is crypto ISACAM key question mark. So we are using unencrypted. So this will be used by your remote VPN. So we'll use key 0. So any key you can mention here. Let us use Cisco, and you need to mention the address as well. Question mark. Address or the host name. So which address you will mention? You mention R2s or R3s. Let us consider we have 10 sites. So that's why we'll use any site. Clear? Enter. This is 5th and 6th message done. So copy paste this on R2 and R3. Now, next step. You need to create transform set. So crypto IPsec. No IPsec. ISACAM bit done. Phase 1 is done. Now 7th and the 8th message. So crypto IPsec, you need to create a transform set. And you need to provide a name here. So again, I will use the name Cisco or anything you can use here. Question mark. These are the algorithms you can use. Can you see? We have SHA. Can you see we have AH and we have ESP as well. So you can use either AH or ESP. So more secure one is ESP because it provides both authentication and encryption, whereas AH only provides you authentication. So let us use ESP SHA 12 HMAC, and this is cipher algorithm. Anything you use. We'll use ESP 3 days. Enter. Exit. Now you need to create a profile. You need to attach under interface tunnel, right? So you need to create a profile now. Crypto IPsec profile. And the name again, you can take anything. I'll take. Then you need to attach transform set transform set and the transform set name. What is the transform set name? Is enter. Now you need to take this profile and attach under the tunnel. So interface tunnel 0. How to attach tunnel protection IPsec profile and the profile name. That is system. So again, this you need to do on R2 and R3. So just copy paste the commands. Do show right section IPsec. I created a profile. Now I'll go to interface tunnel 0 and attach this. So tunnel protection IPsec profile name. Can you see what it's saying? Is on. You need to get this message. This is a bug, so it R1 didn't get, but R2 got it, and you will get on. Sorry, R3 got it, and you will get on R2 as well. So interface tunnel 0. So tunnel protection IPsec profile system. Can you see he also got? He didn't get special one. So now let's share the tunnel. And is it out? That's why it didn't came. Okay, no share. Oh, you have disabled that logging console. Did no logging console? That's why it is not displaying the message. Notice. Now the commands. How to check? First command is show crypto ISACAM policy. This policy you have created already. You provide encryption, hashing algorithm, authentication, group, and lifetime. And this must match on other spokes as well. Next, show crypto ISACAM key. So we created a key that is name is Cisco. What is the address? 0000. Next command, show crypto IPsec transform set. So this is a by default transform set already present. So we have created this transform. Can you see the name Cisco? One by default is already present. You can make use of that as well. So I have created one more transform set that is name Cisco. I used these algorithms. So now, how to check whether your packets are encrypting or not? So just go to R2, just initiate a ping. Now check show crypto ISACAM SA. ISAC SA. 1 minute. Can you see here? Encrypted 6 packets, decrypted 7. This is again a bug. If and 6 packets are encrypting, again 6 packets only should decrypt. Just ping once again. Sorry. Initiate a ping. You see, they have increased to 11. It should be 11. This is how we implement IPsec. So anybody has any doubts? No doubts, I know. Not understood first of all. Okay. Just So I hope clear. Anybody has any doubts?
Now, so tunnel is encrypted or tunnel data that flow.
Data and IP, both. That's why we use ESP. H authenticates only your IP header.
Now, should we see the tunnel encrypted?
You'll be able to see. You will not be able to see. This is ESP, right? You will not be able to see anything because it is encrypted.
GRE we can see.
Yes. So now, what all we did? So we created a policy first. Just a brief. Created a policy. Then we created a key. Then what we created? We created a transform set. Then we created a profile. So inside the profile, we went and attached this transform set. Then we went to interface tunnel 0 and we attached this profile. So tunnel protection, IP set, profile, and the profile name. So 5-step process. And it must match on your hub and spokes as well. So anybody has any doubts online, guys? I'm done for the day. So we'll start MPLS from Monday. Okay. Anybody has any doubts online, guys? Mohammed Ashik, Selva Kumar, Tarun Patil.
No, sir.
Okay. All right, guys. So we'll end up, we'll continue on Monday. So have a nice weekend. Bye, guys.